Good day to everyone. My name is Nelson Morris, son of an Anthony, and my matrix number is 01 DKP 23F 2006. Today, I'm going to explaining about the chapter 11, which is fitting, and describe the various fittings which is found. So now we can clearly view the topic outcomes of the chapter 11, which is fittings. So we have tasked to present about six subtopics, which is describe the constructions of use of a cable stopper, describe the construction of the mast and the Samson post, and how they are supported at the base, and describe the construction of the derricks and the deck cranes, and describe the bilge piping system of a cargo ship. And state that each section of fitted with a screw down non-return suction valve. And finally, describe the sketches bilge strum box. Okay, now I'm going to explaining the constructions and use of cable stopper. Okay, cable stopper and also known as a chain stopper. This is the device which is fitted between the windlass and the hose pipe to secure the anchor cable, which is anchor chain. According to the figure 11.1, it will show the device is used to hold the anchor cable securely after the anchor has been lowered or to be raised. It also prevent excessive loads from being placed on the windlass. And also a cable stopper, it's usually made from high strength forged steel. It is installed between the windlass and the hosepipe. Common type, which is include the chain stopper, devil's claw stopper, and the compressor stopper. It is secures the anchor chain or anchor cable when the ship is anchored. It protects the windlass from carrying the anchor's weight. The cable stopper acts as a safety device that keeps the anchor chain firmly in the position. So now we are going to see the figure 11.1. Okay, now we can clearly view the cable stopper from the figure 11.1. Okay, now I'm going to be explaining the constructions of the masts and the Samson post and how they are supported at the base. Okay, first of all, we are looking the first material, which is the mast. Okay, figure 11.12 it shows the mast is a vertical steel structure which is fitted in the ships, and it's also support the navigation lights, antennas, radars, signal flags, and the communications equipments. The modern masts are usually made from the welded steel sections. Now we are see the Samson post. Okay, in figure 11.3, which is show the Samson posts are strong vertical steel post fixed on the deck. Okay, the mast is fitted in the ships, and the Samson post is fitted on the deck. Okay, both mast and the Samson post are welded to a strong deck foundation, and also the load is transferred safely to the ship's hull structure. The foundations are reinforced with the stiffeners and the supporting beams. The strong foundation is ensured that the mast and the Samson post can withstand heavy forces during the operations. So now let's see the figures. So now we can clearly see what is the mast and the Samson post. The figure 11.2 it shows the mast, and the figure 11.3 it shows the Samson post.
Have a good day to everyone. My name is SUGEN Analalaki HARIRAU. My matrix card number is 01 DKP 23F 2001. So today I'm going to talk about describes the construction of derricks and deck cranes. Based on the figure 11.3, a derrick is a cargo lifting device consisting of a steel boom attached to the mast. It used wire ropes, winches, and pulleys to lift cargoes. The boom can be raised, lowered, and swung to different positions. Figure 11.4 shows a deck crane is permanently mounted on a foundation base and fixed pedestal with a rotating turret and operators cabins for controlling cargo operations. It is use a jeep, that means boom, steel wire ropes, pulleys, and a hook, while the slew ring connection allows the crane to rotate for efficient cargo handling. Modern deck cranes can rotate through 360 degrees. They improve safety and lifting efficiency. Deck cranes have replaced derricks on many modern cargo ships because they are easier and safer to operate. So this slide is based on the example images of the derricks and deck cranes. The figure 11.3 is about derricks and the figure 11.4 is about the example picture of deck cranes. And this slide is about the describe the bilge piping system of a cargo ship. So firstly, the bilge piping system removes water, oil and other liquids that collect inside the bottom of the ship. Figure 11.6 shows the main piping runs longitudinally from after to forward sections. Port and starboard manifolds collect fluids across the compartments. Gravity drains fluids into bleach wells at the hull's bottom. Bilge pumps transfer liquid from wells to central storage tanks. Tanks also correct purifier slash water and air cool condensate. Figure 11.7 shows the oily water separator, that means OWS, filter pollutants from the seawater. Waste oil stays on board, only clean water is discharged overboard. Water collects in the bilge wells. The water is then discharged according to MARPOL regulations. It prevents flooding, protects machinery, and maintains the ship's stability and safety. So, this slide is all about the example pictures of the bilge piping system of a cargo ship. So, the figure 11.6 is based on bilge piping system drawing, and the figure 11.7 is bilge pump system, piping system.
Hello,
Thank you.
my name is Darwin Analaki Anandan and my matric card number is 01 DKP23F at 2004. Now I'm going to explain about state that each section is fitted with screw down non-return suction valve. A screw down non-return SDNR valve is a valve that combines two functions in one unit. Firstly, it can be manually open or manually closed using a hand wheel, and it also prevents water from flowing backward through the pipelines. The valve body is made from cast steel and bronze. It contains a valve disc, a valve seat, a spindle, and a hand wheel. The valve is installed between the bilge suction pipe and the valve manifold. It also operates manually by turning the operating hand wheel. It allows the bilge water to flow from the bilge suction pipe to bilge pump. It prevents reverse flow from the water pump back into the bilge. It isolates individual bilge suction lines during maintenance, and it also protects the bilge pumping system from flooding. Now I'm going to explain about that each section is fitted with screw down non-return suction valve. Based on the figure 111.8, water enter the sea chest through the sea suction grate. The sea suction valve controls the sea water supply. Bilge water enter the emergency bilge suction pipe. The water is passes through the SDNR valve. The valve manifold direct the water to the main circulating pumps, and if a water tried to flow backward, the SDNR valve automatically close to stop the reverse flowing. It also prevent black flow of water, and it protect the bilge pump from damage. It improve the ship safety during emergency bilge punching, and allow the maintenance without affecting other bilge lines. This figure 11.8 is the screw down non-return suction valve. Now I am going to describe sketches a bilge drum box. A bilge drum box is a protective filter fitted at the end of the bilge suction pipe. It usually made from steel or bronze. It has a perforated or mesh cover. The holes allow the water to pass while blocking the large debris. It prevents the rubbish from entering the bilge pump. It protects the pump from damage. And it also keeps the bilge piping system free from blockage. It improves pump efficiency, it's reduce maintenance, it's extend pump's life. And figure 11.9 show the bilge sum box act as a filter that prevents solid particles from entering the bilge pumping system. And here we can see the example of bilge strum box.
So this slide is about the summary notes for our presentation. A cable stopper secure the anchor cable and protects the wine glass. Master and Samsung post a strong steel structure supported by reinforced foundations. Derricks and deck cranes are used for lifting cargo, with deck cranes being more efficient. The bilge piping system remove unwanted water from the ship to maintain safety. Screw down non-return valves prevent backflow and isolate bilge sections. Bilge strum boxes filter debris before water enters the bilge pump. That's all for me. Thank you.
And these websites and books we use as a reference to create our PowerPoints. And that concludes our presentation for this topic. Thank you very much.